Today we are on really the last main lesson, and then tomorrow we'll finish it up, lessons on area, and that is finding the area of regular polygons. Today our focus is going to be on using regular polygons with special right triangles, and then tomorrow we'll deal with those that are not. So again, just to get those special, the first one is that 45, 45, 90. So if that side is x, this is x, and this is x radical 2. And the 30, 60, 90, if this is x, we know the hypotenuse is 2x, and the long leg is x radical 3. And then finally, that third option is using Pythagorean's theorem. So a squared plus b squared equals c squared. And just a reminder, c has got to be your hypotenuse. So going down to the figure at the bottom, our goal is to find the area of this octagon. We need a few pieces of vocabulary in here as well. The first thing is regular polygons. So all of the polygons that we're going to look at have all the sides congruent and all of their angles congruent as well. Now, why is that important? Because what we're going to focus in on is, let's take a look at that shape right there. If I can simply find the area of that triangle, if you notice, we then have 8 triangles that are the exact same thing. So in order to find the area of that octagon, what we can do is simply find the area of one of those triangles, which is base times height, and then multiply that by 8. So let's look at a couple pieces of vocabulary. First of all, we know what the base is in a triangle. That's this guy right here. It's the base. When we talk about it with regards to a regular polygon, it's also one of the sides of the regular polygon. Second, we talk about the height. The height is this piece right here for our triangle. And again, inside that regular polygon, here's one of the new key words. It's called the apothem, or sometimes called the apothem. Finally, we've got the radius. The radius is the distance from that center to any one of the vertices. So this length right here is called the radius. And I'm going through these vocabulary because in different situations you're starting with a different piece of given. Sometimes you're starting with the apothem, sometimes it's a side length, sometimes it's a radius. So let's look at this particular case, and what I'm really going to focus in on is just that triangle. And I'm just going to redraw that triangle over here. It tells me the side length is 5. That means this length here is 5. So with respect to my triangle, this length is 5. It tells me I have an apothem of 6, which is this distance right here. So inside my triangle, I have that height to be 6. So if I can find the area of the triangle, I simply multiply it by 8 because there's 8 of those triangles inside the octagon. We've got then 8 times 1/2 times the 5 times the 6. 8 times 15, and 8 times 15 ends up giving us an area of 120 units squared. Now while we're here, if you look at your formula sheet, if you look under regular polygon, it does give you another formula, and let's kind of work our way through that other one. So I'm just going to put an or in here. That or is 1/2 apothem times perimeter. Let's see how that formula works and see why it is actually the same thing as this one. So again, we've got our 1/2. Our apothem is right here, which we were told is 6. And then to find the perimeter, they're talking about the perimeter of the whole regular polygon. Well, if you notice, you've got 8 sides, and each side is 5. So take a look at what we did here versus here. There's your 1/2, there's our 6, there's our 5, and there's our 8. So at the end, we still end up with the same answer. We've just approached it a little bit differently. I'm going to stick with my method up here, but again, wanted to show you because some of you might pick that other option. Okay, moving along, the next shape that we have is a hexagon. And again, all I really need to do is find the area of one of those triangles inside the hexagon because they're all the same. So I've got 6 triangles. We have 6 1/2 base times height. I've been given a side length of 8, and that's all I have. So I don't have the height. So think back to what we first put on our notes today. That must mean I can use one of those special right triangles or Pythagorean theorem. So let's go ahead and pull that triangle out for the moment. This is 8. I'm going to go find this angle right here. So if you can envision, if I'm standing in the center of this polygon and I go all the way around, I've got 360 degrees. And there's 6 of those triangles. So I'm going to do 360 divided by 6, and then I have to turn around and cut that in half, and we end up with 30 degrees. And I'm going to pause, just give you a second to look at it. Again, all the way around is 360, divided by 6 gives me this whole angle, but I'm cutting that in half because I need to go find the height. Now if you notice, you've got a 30, 60, 90. We know the base is 8, and to get from the short leg to the hypotenuse, or to the long leg, all we have to do is multiply by radical 3. So I'm putting that radical 3 off to the side, picking up my calculator and multiplying everything else. So we're doing 6 times 1/2 times 8 times 4, and we get 96 radical 3. All right, let's go on to the next one. And again, what I'm doing is I'm just cutting up that triangle into 3 separate triangles. Yes, you can use 1/2 base times height, but I'm trying to force us to practice this method. I see 3 triangles. That is 3 1/2 base times height. I've been given a radius of 6, which means this little piece here is 6. So let's go focus in on that triangle for just a moment. And right now I don't have the base or height of this triangle down here. So again, same procedure we did before. I'm taking 360, I'm dividing it by 3 to give me this whole angle, but then I have to cut that in half because I'm dropping in that height, and we end up with 60 degrees. So now we're back to a 30, 60, 90. I've been given the hypotenuse, so to get back to the short leg, I divide by 2. To get from the short to the long, I multiply by radical 3. So we've got 3 times 1/2. If this is 2 radical 3, the whole base would be 4 radical 3, and then we've got a height of 2. Again, I'm going to cast that radical 3 off. I'm typing in 3 times 1/2 times 4 times 2, and we end up with 12 radical 3. Again, giving you just a minute to get caught up and look to see what we did. Again, my goal is 3 of these triangles, which is what I have here. All I had was this length right here, so I didn't have the base or the height of that triangle. I pulled that triangle here, and the key is figuring out what type of special right triangle do you have. So 360 divided by 3 divided by 2 lets me know this angle up here is 60, this angle down here is 30, and I'm back to a 30, 60, 90, and I'm just noticing I made a mistake. 6 divided by 2 would make this a 3, and this would be a 3 radical 3. So we need to change this to a 6 radical 3, Apologies for the mistake. 3 times 1/2 times 6 times 2 actually gives us an 18 radical 3. Okay, let's move on to the next one. We're starting off with a square. And I've been given a radius of 20. Okay, and again, I get you might choose a different method, but we're trying to stick with this method here just to give us a little bit more practice. So in this particular case, I see 4 triangles. I see 4 times 1/2 base times height. Again, I don't know the base or the height. Let's go pull that triangle out. All I have is this length here is 20. So just like we did on the ones above, we have to go figure out what this angle is. We are doing 360 divided by 4, but then again I have to cut it in half. That means this is a 45-degree angle. Let me zoom in for us. So I'm going from the hypotenuse back to these legs. 20 divided by radical 2 gives me 10 radical 2. And this is a 10 radical 2. We've got 4 1/2, the length of this base. This is 10 radical 2, this is 10 radical 2, so that total length is 20 radical 2. And then we've got our height, which happens to be a 10 radical 2 as well. Now up here, I had an odd radical, meaning there was only one radical, but these radicals are going to cancel out, so you can type in exactly everything that you see. So we've got 4 times 1/2 times 20 radical 2 times a 10 radical 2. And looks like I goofed on mine. And we end up with 800 units squared. And just double checking my answer. Okay, so your assignment tonight is actually on the next page, so I'm going to go ahead and go through a few with you, just to help you out as well. All right, so the top part is really just focusing on how do I figure out what special right triangle it is. I'm going to start by finding angle 1. That's this whole angle here. So we are doing 360 divided by 3, which gives me 120 degrees. So that whole angle is 120, and so is this one. But again, I've dropped that piece in. I'm going to turn around and divide it by 2. So I've got 60 degrees up here, which means I have a 60, a 90, which forces angle 3 to be a 30 degree. Same thing here. To find angle 4, I'm taking 360, I'm dividing it by 4. That gives me 90 degrees, but if you look at this one, I'm then cutting that in half, which gives me 45, which means now I'm looking at a 45, 45, 90 triangle. You can go ahead and do number 3. I'm going to jump to number 5. The area of a decagon. A decagon is 10 sides. And in this case, they actually gave me the perimeter. So I'm going to use that other formula instead. I've got 1/2 the apothem times the perimeter. I've been given that apothem, which is 4, which represents the height of one of the triangles. And I've actually already been given the perimeter. So 2 times 25, and we end up with 50 feet squared. Okay, I'm going to pause it for a second, start working out number 6 because I don't have a whole lot of time. Okay, I pulled some pieces out. I found this angle here. I'm going from the hypotenuse back to the short leg. That would be 10. My long leg is 10 radical 3, and I'm ready to plug in. That whole base would be a 20 radical 3. The height would be 10. Again, cast that radical 3 off and multiply 3 times 1/2 times 20 times 10, and we end up with 300 radical 3 feet squared. Do the best you can tonight. We will pick it up some more tomorrow.